Hello everyone, my presentation is on analysis of the air or pressure inside the tunnel by 3D finite element method model which created in LS software. Hello, my name is Ashutosh Bhagwat, doing MTech in Tunnel Engineering School of Civil Engineering from Dr. Vishwanath Karad MIT World Peace University, Kothur, Pune, under the guidance of the Dr. Professor Sandeep Potni sir and co-guide Dr. Aditya Rana sir. This is my content line of my presentation. It contains the small introductory part of the air or pressure and the need of the project and scope of the work. On the basis of need and scope of the work, we finalized the objective of project and created a model on the LS software by considering the all material parameters with the geometry. Introduction. What is air or pressure? The definition of air or pressure is the pressure which is caused by the shock wave which is above to the atmospheric pressure. It is called as air or pressure. Air or pressure is also plays a very crucial role in the tunnel, which is caused by the blasting activity inside the tunnel. As according to the Ali in 2019 and Amir in 2017, there are two most important parameters for the air or pressure are the charge per delay and the monitoring distance from the blast phase. The effect of the wind velocity and the temperature, these factors are also affect on the air or pressure. As per the A.D. Mohammed in 2015, according to all these factors, various methods used to find out the air or pressure by adopting the artificial neural network method, the genetic algorithm method, and the other algorithm, etc. But here by using the LS software, which is basically finite element model software, we create a model to evaluate or analyze the air or pressure problem inside the tunnel which is caused by the blasting. Need of project. Blasting operation is produce the very crucial environmental problems which is also causes to the major damage to the nearby areas. And according to the Manoj Khandelwal in 2005, only the 20 to 30% of blasting energy which is utilized to rock fragmentation or to break the rock, and other energy will spread into the air blast or air or pressure or vibration, ground vibration. And the air or pressure is the one of the most important parameter in the blasting operation, which is very hard to predict, and as well as which is eventually controlled to minimize the potential risk of the damages to the surrounding area near to the tunneling execution of the tunneling alignment. Scope of work. Efficient use of the blasting energy, that is the more than 30% to the fragmentation of the rock mass as per the geological strata. The reduction of the environmental damage which is generated due to the blasting inside the tunnel in the form of air or pressure. Prediction of the air or pressure damage and the reduction of its impact by application of the remedial measures. These are the scope of my works. The factor influencing the air or pressure. There are some factors which are affecting on the air or pressure. In that, the factors are as following. In first factor is the geological discontinuities, second is the blast geometry, and third is the vegetation, fourth one is the distance between the blast phase to the monitoring point, and next is the meteorological the condition, and then the direction of the blast. After that, the maximum explosive charge per delay, and at the end is the surface topography. In all these factors which are affecting on air pressure, there are two very important factors which affect on the air or pressure. The two factors are is in red color. The first one is the distance between the blast phase or blast source to the monitoring point, and the second one is the maximum explosive charge per delay. On the basis of our project or introductory part, you can see we finalize the object by referring the different types of research papers based on the air or pressure to predict the air or pressure which is caused by the blasting inside the tunnel using the finite element method. And second one is to evaluate the effect of the different blast design parameters on air or pressure using the 3D finite element model. This is in modeling on LS Dyna. This is some rough idea of modeling in LS Dyna. By considering the all parameters and material as per the site condition are as follows. In that tree is there, then the material properties. In material properties, which type of rock on the site, which type of explosive used for the rock breaking on the site, and what is the air, the density of air, and other factors. Then another third one is the ALE. ALE is the arbitrary Lagrangian Eulerian method. ALE is a very good and suitable method for the any blasting problems. By considering the multi-material group into this LS Dyna software, we detonate the explosive at different delays, and giving the ASCII option in the LS Dyna is a ASCII option is a type of output option. In this output, we analyze the pressure, internal energy, kinetic energy, displacement, and as well as resultant velocity and etc. The material parameters. Considering all the parameters and material as per the site condition are as follows. There are three main material which is used in the LS Dyna software. First one is explosive, second is air, and third one is basalt rock, which is encountered at the site condition on site. As per the John Wilkins Lee, the explosive parameters density of explosive for emulsion explosive is 1200 in kg per meter cube. The detonation velocity is 4200 in meter per second. The PCJ is a Chapman Jougart pressure in gigapascal, which is 7.89. Then the A, B, R1 and R2 and E0 are the coefficient of the emulsion explosive, which are A is 191.72 in gigapascal, B is 1.316 gigapascal, R1 is 4.63, R2 is 0.58, and W is 0.37, and E0 is 1.93. These parameters are according to the John Wilkins Lee parameter. Another as per the J. Liu in 2008 says the density of air is 1.28 in kg per meter cube, and the C0, C1, C2, C3, C4, C5, C6 are the coefficient of the air, and the E0 is the initial internal energy, which is in Pascal, which is 2,50,000 in Pascal, and V0 is the initial internal volume, which is 1. And the third material is the basalt rock. This basalt rock is which is encountered on the site, actual site. On the basis of actual site basalt rock, the density of the rock is 2600 in kg per meter cube. The elastic shear modulus in MPa is 700, and the Poisson's ratio is 0.22. The PHI angle of friction in radians is 0.56, and the cohesion value in MPa is 65, and the PSI dilation angle in radians is 0.24. The geometry for the modeling. In geometry for modeling, the parameter which is considered is width of the tunnel, height of the tunnel, area, drill holes, and the total explosive which is used to break the rock inside the tunnel. In actual, the width of tunnel is 17.9 meter. The height of tunnel is 7.4 meter. Similarly, the area of tunnel is 100 meter square, and the drill holes are the 160 number, and the total explosive which is used to break the rock or for the execution of the tunnel on actual site is 385.620 kg. This all dimension are very large to make a model, and it require more time for simulation. So by considering the specific drilling considering specific drilling, we consider the width is 2.24 meter in model, and we consider the height in model is 0.92 meter. According to the area is 3.106 meter square, and drill holes are 5 number, and the total explosive used in the model is 12.09 kg. This red box is a geometry of my model, which contain the height is 3 meter, width is 3 meter, and the length is 100 meter. This red box of my geometry model is also considered as a basalt rock. In rock or red box, there is a one small box which is blue in color, which is air column, which dimension is 2.24 meter in width, 0.92 meter in height, and 90 meter inside the red box, which contain the air column. And after the 90 meter inside the tunnel or inside the box, the drill hole is or charge is put inside this box into 90 meter from the face. This is my charge pattern which we used inside the tunnel for blasting in model. In bottom there are 3 charge which is 0.2 second, and above 2 charge are at the 0.1 second delay. By considering the specific charge is 0.96 approximately. The total volume per hole is 2.48 cubic meter approximately. This is the element box which contain number of elements into this box, and there you can see the one element is on right side, which can show the dimension of one element, which is 0.1 meter by 0.1 meter. So the size of each element is 0.1 meter, and so the total number of element in my model is 9 lakh with the 2 tracer point. The total time required for simulation is 39 hours. In result, we consider the 2 model. In model 1, which contain the mounting distance is 100 meter with 2 tracer point, and in second model in which the mounting distance is 50 meter considering the 2 tracer point. In that the sound pressure level LP is measured in decibel, means air or pressure, which is also measured in the decibel by using the formula LP is equal to 20 log to the base 10 in bracket P divided by P0, whereas the P is root mean square sound pressure and P0 is a reference sound pressure. It is usually 0.00002 Pascal. These are the result of the air or pressure at 100 meter from the blast distance in model 1. In model 1 there are 2 tracer point. You can see in tracer point 1 in model 1, time is on x axis, which is in second, and the pressure is on y axis, which is in Pascal. The air pressure at 100 meter from the blast at tracer point 1 is 131.48 decibel. Means the total pressure of tracer point 1 at 100 meter or in model 1 is 0.1014 e to the power 6 in Pascal. From this total or measure pressure, we can reduce the atmospheric pressure, which is 1 lakh Pascal, and the difference of the major pressure to the atmospheric pressure is 75 Pascal, which is shown below the figure, and this pressure is 75 Pascal, which put into the equation or formula. So we have got the air pressure is 131.48 decibel at 100 meter from the blast in tracer point 1 model 1. Similarly, in tracer point 2, the difference of the major and the atmospheric pressure is 155 Pascal, and putting this pressure into the formula, we have got the air pressure is 137.78 decibel at the 100 meter from blast in tracer point 2. In model 2, the result shows the air pressure at 50 meter from the blast distance. So in model 2, tracer point 1, the difference between the major pressure and the atmospheric pressure is the 375 Pascal. This pressure put into the formula, and so we have got air pressure for 50 meter in tracer point 1 is 145.46 in. Similarly, in model 2, tracer point 2, we have got difference of the pressure got 475 Pascal, and according to this pressure, we have got the air pressure 147.51 decibel at 50 meter from the blast. This is the summary of results. In first column, the tracer point is there. T1 and T2 are in model 1, and T1 and T2 are in model 2. In model 1, there are two tracer point, which is 100 meter from the blast source. So we obtain the air pressure from model which is in tracer point 1. In model 1 is 131.48 decibel, and in tracer point 2 in model 1 we have obtained the air pressure is 137.78 decibel. Comparing to model 1 obtain air pressure with actual air pressure at the site in decibel, which is 134.64 in tracer 1 model 1, and in tracer point 2 in model 1 we have got 134.64 air pressure in decibel at actual site. The error between the model 1 air pressure which is less than 3%. Similarly, in model number 2 tracer point 1 or model number 2 tracer point 2, which are the monitoring distance is 50 meter from the blast source, and in model 2 in tracer point 1 we have got air pressure 145.46 decibel, and in model 2 tracer point 2 we have got 147.51 decibel. Comparing to this air pressure with actual air pressure on site on the distance of the 50 meter, which is 142.09 in decibel, by comparing obtained air pressure and the actual air pressure at the site, we have got the error which is less than 3% in model number 2 tracer point 1, and in model number 2 tracer point 2 we have got the less than 4% error comparing to actual air pressure at site. On the basis of the result, we have concluded that the overpressure, which is directly proportional to the maximum charge per delay, means if the maximum charge per delay or MCPD will increases, then according to this the pressure will also increases. And another is the overpressure, which is decided by the distance between monitoring blast source to the monitoring devices. Means if we increase the if the distance is more, pressure will less, and vice versa. And another is to analyze the air pressure from the 3D finite element method, which is dynamic model. The LS Dyna software is more accurate and efficient for exclusive problems. And next is the error between the simulation and the experimental error are vary in small by using the more number of elements. if we use more number of element into the software or in our model, then we have got accurate result. So the element into the model, but if you consider the more number of element, then it require more time for the simulation and getting the result. These are the references which we go through it, and it will help to complete our project. Thank you so much.